Alright everyone, so in that last video I went through how to do all of the properties set up and do property analyses in our system. What I want to do now is look at how can we do set up a process simulation. And so to do a simulation we click simulation and we're going to go into the flow sheet now. And so I don't know what a cheat sheet is. It's not a cheat sheet, it's just a flow sheet. Okay. So anyways, in the flow sheet, we have the ability to add in whatever we want, any kind of unit that can be modeled in Aspen into this sheet and connect them together with a variety of different streams. They can be material streams, it can be energy streams, they can be work and so forth. So these are all a lot of things we can do, but look here. Now down below, you have all the units that you can add into this box. You can click here and go through and see there's mixers, separators, exchangers, reactors, and so forth. So to first start off with, we're going to do a very simple single unit system. And we're going to do a flash system. You'll notice there's two flashes here. Flash 1, what does it mean? Well, it highlights over and you can't really see it, so I'm going to move this to the side so you can read the whole highlight. Hopefully you see this. But 2 outlet flash, models, flash drums, evaporators, etc. Using rigorous VL or VLL equilibrium. The flash 3 models 3 output flash, where you have with VLL. So for the flash 3, we're going to have 3 outputs, assuming there's a liquid-liquid interface, as well as not just a vapor-liquid, but a vapor-liquid-liquid separator. Since we're just going to assume we have 2 output streams, we're going to take flash 2. Now, we select here, and we created a flash drum on our flow sheet. Great. As that looks kind of small, you can zoom in by on the wheel, scrolling up, scrolling down, we'll zoom in and out. Now notice, as I have the crosshair X in Aspen, that crosshair means I'm still going to be every time I click, it's going to add another flash drum. So I can add a whole bunch of them. Don't do this. This is dumb. But you can, if you keep clicking, you'll keep adding them. If I don't want to click anymore, I could either go down here to this arrow and click that, and it cancels insert mode, or I just hit the escape key and I eliminate that insert mode. I'm going to highlight a whole bunch of drums and delete them with the delete key and say yes. I'm going to save this one and I'm going to delete these. Excuse me. And you now have a flash drum. We can actually change its name by double clicking it and saying flash, and we can move this elsewhere if we want to make it a little bit more logical where it's going to go, and we can change all the options of this unit by the right click button. So you have a lot of options here with normal interface than you'd expect with a click, right click, and so forth. Notice the flash and units we place in here, this is the default structure or picture it gives it. We can change that by clicking the up and down arrow, and we can change what kind of picture it gives that unit. Some of them are more useful for different kinds of scenarios. I mean, for a flash drum, this is a standard look to that. So now that we got the flash drum in there, we now need to connect our streams. In this case, we're going to add a material stream to this. So the moment we click material stream, you'll notice red arrows pop up around units. These red arrows are the needed required inputs. If there is nothing connected to the red arrows, it is unhappy. So here you can see what these red arrows are. If you highlight over them, it tells you. It says feed, required 1 or more inputs. I'm going to click on that. Oops, I made a double error mistake. So whenever that happens, whenever you make a weird clicky mistake, you can edit them and fix it, although sometimes it looks a little weird. There you go. And we got that back to something a little more rational. And we can call this feed. Now notice, in this flash drum, there's a blue arrow now in the same location. Blue means not required, but you can input that. In this case, we can have multiple feeds coming into that flash drum. We don't want to do that, but we could do that. So let's look at another material stream. Now on the top, we can collect here. And now notice, if I click and hold, I'm just clicking and holding right now, I can move this left and right just to make it If I want to add multiple streams, it may be more convenient to have these go side by side. But for this purposes, I'm just going to have it here, and I'm going to leave that stream there. That's nice and connected. Now, the one thing I'm going to emphasize, okay, we're going to connect the bottom stream. Look, there are two arrows. If you never know what an arrow does, if you never know what an arrow does, highlight over it, and you will see it'll tell you what it does. It says here, liquid stream required. So you're going to want to use that. Over here, almost all of your units are going to have an extra blue output stream called the water decant for free or dirty water. This allows for you, if you have impure streams or you're expecting water to be accumulating in the system and so forth, you can add that in. These are not required, and one of the most common mistakes I see in Aspen is students on the bottom click the water decant stream to connect to it as opposed to the actual liquid required stream. So don't do that. No clicky on the water decant stream. No clicky there. Do not do that. So if you can avoid that, that would be very good. So now that we got all of these connected, we know we're happy because the flow sheet right now is blue. It no longer has a little red thingy because it's all the streams it knows it needs are connected. And if I create a new stream, you'll see flow sheet becomes now red because I've just created a random stream that has an input but no output, or there's nothing connecting this. This is a stream in virtual space that's just going nowhere, and it doesn't like that. So for as long as we have streams that are doing this, or we have blocks that aren't connected, this will be red. But once everything is connected, that turns blue and it's happy. So we're going to hit escape. I'm going to select this. I'm going to delete this stream. Good. And so now we're back to the streams we want. I'm going to rename these by double clicking, and I'm just going to call this vapor. Now the stream names, you're not allowed to have spaces. It's very limited in terms of what you can do. The spacing, I think, is limited to 8 characters. So just realize that there are some limitations in terms of stream variable names that you have there. But there we go. We have a complete unit set up. Great. You'll notice we still have a lot of red things over here not fully set up. But we can start setting those up. If we go to the top here, it's yelling at us because it's saying, oh yeah, hey buddy, your component list isn't created yet. So we got to go back to properties. So let's go to properties. Now in properties, we're going to do the same separation that we did in class, and that was the diisopropyl ether. Diisopropyl. I'm going to start with that. Begins, find. We're going to select diisopropyl ether. Close. So that's there. We're going to create a new one. Find. We're going to do the isopropyl alcohol. Isopropyl begins with. Find now. We got a lot of things, but this one right here, isopropyl alcohol. If you can't read it, if it's scrolling, click on the little things side by side, open it up, and so you can see it. Isopropyl alcohol. Yes, that's what I want. Close. Excellent. And so I'm going to call this one ether. Shorthand, because that's the ether we're doing. Rename. And I'm going to call this one IPA, because that's isopropyl alcohol. Alcohol. Why can't I not talk? Isopropyl alcohol. There we go. We have all that. Lovely. That looks good. I'm happy with that. What do we need to do? We still need to change the methods. So we have to go to the methods. And in class, I showed you what happens if we use the ideal. I'm not going to repeat that here because the story there is it doesn't work. So we're going to go back to the UNIVAC model. And UNIVAC. There you go. And we're all good there. So that's all blue. That looks good. We can click next. It says here, next steps. We can either run properties and so forth, or we can just go to the simulation environment. And so let's go there. And it's going there, going. Good. So now, what setup was red before is now blue because we have completely finished all of the units to run. So that's good. So we can click next and see what do we need next. Well, the next thing we need to know is the stream inputs. What are we going to be inputting here? And so in our simulation, I'm forgetting what we had set up, so I'm looking at my notes. Okay, so we can do a separation of input stream at, say, 70 degrees C and 10 ATM, and we can specify the flow rate, and here we can say 100 kilomoles per hour, and then the composition. Now notice here we can change the compositions. We can either put this into composition flow or mole fraction. And here we can specify the stream flow rate. One thing I have to emphasize, do not, if you select mass flows here or mole flows here, do not put anything here. Only use this and this together if you're using mole fraction or weight fractions. If you're using this as the flow components, this should be blank. You'll get lots of weird data or answers if you do it otherwise. So we'll say 0.4 and 0.6. There you go. We have all that. Now we can change the flash type that we're going to have in this if we want. This is the stream, so we can actually specify temperature and pressure, or we can specify a vapor fraction and pressure. Obviously, you can specify two components, and then Gibbs phase rule says that's fully satisfied. So this is just asking you what do you want to specify in this system. And so your feed is completely satisfied. That looks good. We can click the next again, and now it's asking us to change the flash unit system. So for the flash, we're going to specify at 70 degrees, and we'll say 1 ATM. As we specified in class, and so now the blocks are fully satisfied. If we click next, it says all required inputs are run. You can run the simulation now. I'm not going to, because I do want to show you the one other things we want to do. We want to make sure in the setup, and I'm going to go to setup to see if we want to change any of our other basic setups of our system. Do we want to change the global unit set? We can change it here, even though we specified that we wanted metric general. We could change it if we decide to change our mind. Maybe we want to go back to English units. We can do that. We can change it to pure SI units. We can do that. Also, we can change report options, and this is one of the more important things you're going to want to do. You can go here and say what it is you want Aspen to output for you. So for example, in the streams table, we would love to see mole fractions. We could even see mass fractions if we want. We can see flow basis. We can see mass flow basis. Whatever it is we want. We can click on property sets and get transport properties. We can get equilibrium, the fugacity activity coefficients of our systems. We can get thermal data, enthalpy and heat capacities. Let's include that just for no other reason because we can. We can also get transport properties. If we want to know the density, viscosity of our system, yeah, sure, why not? Let's get all of that. These are all things that are going to be reported for the streams. The more we add in, the more stuff we have, so it might be a little bit more unwieldy to read, but we can learn all the stuff that's been calculated behind the scenes. And then finally, you can actually look at items to be included in the blocks report. You can get block results. You can ask it to do a component balance for you if you want. There's a lot of extra information you can do in this system to get reporting options as you want. So I think this is a very useful tool to learn and get information out. So don't always rely on defaults, even though the defaults may be exactly what you need. So now that we're all set up, we can click the magic run button, and in my system, it unfortunately, and I'll show you this right now, it automatically tries to start the economic evaluation. I don't want it to, so I'm just going to say cancel on that. If you get the option to ask to run economic evaluation, I would just say no for now. For purposes of this class, you may do that later in senior design, but for now, just you don't need to run that. But you'll notice it's done. I don't get the little Windows it's done symbol. I can go to results summary and see that it's done. I can click over here and run down. I can go to run status. I can go to my streams, and you can see here run status. Calculations were completed normally. We can get all of these information that we'd want. I can go down to streams. Now I'm just going to go to streams run. Oh, I'm sorry. Go to this one. This is better. We can actually go here and see all the streams data that we want to do, that we wanted to get. And you'll see now I can change the order of the streams. If I wanted the vapor and liquid first and put the feed last, we can do that. however you want. So you don't have to rely on the default ordering. As you scroll down, you'll see vapor fraction, mole flows of all the different streams, enthalpies. You'll see down here the vapor phase, enthalpies. So obviously for vapor phase, there's only one vapor phase, and that's here, and so you're seeing the data there. Liquid phase, enthalpies and information, that's all down here, and those are liquid. So excellent. So you can see how these are playing around. And probably the most important result in this separation is this right here. And looking at the separation of ether and the alcohol at the flash unit. And you can see the mole compositions of the ether is 20% in the liquid, but almost 50% or 49% in the vapor phase. So you enriched the vapor phase with the ether, diethyl ether. If you look above here, that would make sense. So we can see all below here that this is all starting to agree with the results that we wanted to see, right? And this is gives us a sense of how the separation is working and how informative it is and what we're getting out of this. So, with all of that said, I think we can. You have other ways of getting out information on this. We can say copy all. If I say that, then I can open up an Excel Excel workbook, and let me bring it over to the screen window so you can see. I clicked copy, and if I paste in here, you'll see now we have all that stream data information now placed in Excel, which you can then use to manipulate, edit, calculate, and verify everything you wanted to know. For example, does the mole flow balance work? Does this plus this minus this work? And sure enough, it does. The ins equals the outs, so the balance works out very nice. So you can verify all of your information in Excel, what you see in Aspen. We can now look at around the flash unit itself. You'll see each block you place in each unit will have results of its own present, and you can see here all the output results. What is pressure was calculated. Some of these were reported, plugged in, and some of them are calculated. For example, here the flash vapor fraction was calculated. 69% of the flow rate is coming out in the of the input is coming out as vapor, hence the vapor fraction. Heat duty, you can see how much what the heat duty of your block is, and I can convert this to kilowatts, and you can see what the flow rate is. You have the ability to change units here as well, so it's very nice and very convenient system. You can also see the vapor, the phase equilibria information as well, and this is just your X, Y for the ether, the XY for the IPA, and your K value, your K parameter that's calculated as well. So you have a lot of extra information. This isn't as interesting for a flash unit, but the phase equilibrium gets very useful and very interesting when you're looking at a distillation column. So this is, in a nutshell, all of the things you can look at and get information from within Aspen, and just how you can actually get more out of the units as you're using this. You're more than welcome to start playing with other things like the custom outputs. Here it allows you to actually change the units and in the feed and change things. So if you need to customize this to something more useful for your reporting purposes, you can do it here, and then you can obviously highlight all this, copy and paste. But if you want to put the stream table into the actual flow diagram, you have to go back to the streams. You have to click stream table. It uploads it there, and then you have the ability to make a pretty picture, output it, and go from there. So I think we'll stop for that for now, and in the next videos, I'll try to put them up online tomorrow, will be on the electrolytes that we did on class on Thursday, and we'll start to also show some of the things that we're planning on for Tuesday's lecture as well. So thank you for listening, and have a wonderful weekend.